Hello everyone, good evening. And so we can start the session now. So this is our fourth session, and so we Jack Tech and Dream Coders in association with IBTC organizing this 7 days internship program, and this is a fourth day of your 7 days training program. So I have added this will be the student diary. Like after 7 days training program, after the 7 day internship program, you will be submitting this. Okay, you have to submit, we'll be sharing you a Google form. You have to submit this by putting all your project in this. I have added instruction, and this document link, this Google document link is available in our WhatsApp group. You can take for your submission. When you do submit, you need to go to file, you need to make a copy, right? So after you make a copy, you can name this like a smart system with Arduino and ESP32. Just before student ID you can put your name. So for example, if your name is Karin, you can put ESP32 Karin student ID, or Sham student ID. You can have any name. And so you have to enter your name, your year, department, your college name, right? And you see like each session, the recording session is available here. You can click this, and if you need to go through this session later, you can go through the session. And session activity link. Session activity link is the activity which we do on session. The same topic which I will do, okay, you'll be also trying, right? You need to submit that, right? That like for example, if you are doing this activity today, you have to submit that as a session activity. The session activity is activity what we do in the session, right? And assignment, so you need to submit your assignment. Your assignment will be very easy, like when you know how to, like if you know how to if you understand very clearly with the session activity, your assignment you can easily do that. Okay, it will take only like 10 to 15 minutes for completing each assignment. So you have to submit your assignment, your session activity assignment link for all the session, for all the 7 days. So this will be like once you submit all this link, and once you submit this document, you'll be like you have 7 days or 10 days to submit this document. You can take 10 days to submit this document. Once you submit this document, your certificate will get processed, and this document is very important. This document have like is more valuable than your certificate. I can say this document is more valuable than your certificate. All your learnings, okay, whatever you did, whatever like training you undergone in the 7 days, like it is a proof for your 7 days training program. And when you submit your certificate, like in your college, you can also uh, just download this, and you can share this as a report. Okay, you can share this as a project, like a internship report, right? Okay, ma'am. So now we can start with today's session. So it is an interesting topic today. We'll be doing like a smart entry automatic door opening system with servo motor. Everyone can able to see my screen, right? Everyone can able to see my screen, right? Can you confirm? You can put your comments in chat, or you can unmute your mic and give a reply. So can you all able to see my screen? Okay, ma'am. Yes. Okay. Yeah. Yes. So today we'll be doing a smart system. Okay. It is actually a smart entry automatic door opening system with servo motor. So you would have noticed there will be an automatic door when you go for a like a malls, or when you go for a cinema theater, right? Complex, you can able to see like in your institution, in your college, you might have automatic door in a reception, right? So we can see like we can create a simulation of that automatic door. We are going to create a simulation of that automatic door. So you have to notice when you're close to the door will automatically open, So there will be a sensor. That sensor can able to detect your presence, and door will automatically get open. So there will be a sensor, there will be a microcontroller. Okay, there will be a motor to open the door and open and closing the door. Okay, the motor which we are going to use here is servo motor. I will show you a small animation video also. You can see automatic door video. When someone enters near the door, there will be a sensor. You can see there is a sensor here. The sensor, like another side also, there will be a sensor. This sensor will detect the human presence, and once it detect a presence, it send a signal to the microcontroller. Microcontroller can be an Arduino board, or it can be a ESP32 board, or it can be PIC microcontroller. It can be any microcontroller. So it will receive it receives a signal, and it will send a signal to the motors to open it, right? So this is what we are going to create. I will show you the simulation output also, then we can start with the full from scratch. I will show you the simulation output, then we can start building this from a scratch. So you see, I'll do start simulation. We also added a LCD here. LCD is not required, but if you can also add a LCD. Like when you do this as a prototype project, so if you are doing an embedded system project, LCD is always will be used in an embedded system project. I'll do start simulation. So when I do start simulation, we are going to consider this servo motor, this point, as a closing. You see, like it actually like getting closed. So you see automatic door is actually closed now, right? And if you need to open the door, so we no need to manually open the door. So when you come in front of this sensor, there will be a sensor in front of a door, and so this, you see there's a ball type like a shape here. This is used to actually like to simulate a motion here, right? If it is a real hardware, you know that it will automatically sense. To simulate this, we have a this round shape. You can assume this as a some person entering in front of a sensor. So you just need to move this. When you move this, it means that it will trigger a signal. Someone is in front of a sensor, it should open the door. We can see how it works. I'll move one more time. So you see, like welcome door opening, and door get open, and a person can enter. So this is just a simulation we are going to create. This is what we are going to create now. You already know how to program a digital sensor. We already programmed a switch, and you know how to connect a LCD. You know how to use a breadboard connection, and I will tell you how to use a servo motor also. In the session we can see how to use a servo motor. Last session when we use LCD module, we are using a library to connect your LCD, to program your LCD module. Same way for servo motor also we should use a library. So we can start this from a scratch. I will do stop simulation. So this is the goal. Okay, this is the goal of this session. This is what we are going to create now. So to start from the beginning, I'll just click on this Tinkercad logo. If you're in this main page, this page, you can just click on a Tinkercad. Once you're into this starting page of your Tinkercad, so you need to, all your previous designs will be available here. So you see, like I'll go for here. You see there's a classes. So if you I hope everyone have joined this class also. Like whatever activity you do, I can able to see when I get into your account. I'll just create plus create. You have three options. We can do circuits. Once you open this, you are into the main application, right? So now you see there is a work area, workspace, and there is a components in the right side. You have all the components in the right side. So we can pick the components one by one. Wait a second. Okay, so we need a Arduino board. I'll take a Arduino board. I'll take a breadboard. We can take a Arduino board. We can take a breadboard, and LCD we can take later. We can connect a servo motor. So we need two servo motor. I'll take two servo motor. This servo motor is like motor, right? So not like this is not like a normal motor which spins continuously. When you use a servo motor, you can able to control the movement of the movement of this. We can able to control like to precise angle. If you need to rotate this motor shaft like 90 degrees, you can able to rotate it 90 degrees. If you need to rotate any angle between 0 to 180, it is possible. So this servo motor position, you see like position. So if you do continuous, it can, you will get this one. I'll choose this as a positional. Okay, it is actually now in, okay, now it is actually in a 0 degree. This angle this is, this angle by default it will be like 0. Okay, and if you move 90, so it will go like this. It will change, it will move from this 0. If you set an angle to 90, it will rotate to this 90 degree. It won't continuously rotate, so it will move to some specific angles. This servo motor will be functioning. So I'll take a servo motor. You can have a servo motor anywhere over here. And before this, I will do like connect a VCC. You know that this positive will be connected with 5 volt. I'll take a positive, I will connect it with 5 volt, and we'll be using a red color for positive. And you can connect a negative. Negative will be connected with a ground. Negative will be connected with the ground. And for negative or ground connection, we'll be using a black color wire, right? And when we have the servo motor, I'll just have the servo motor. You can have a servo motor anywhere over here. So even you can loop this portion also to positive, negative. So you see like this. Now this entire line can be used as a positive, and this entire line can be used as a negative. If you need to loop this positive to this positive, you can extend your wire. Take a wire, you connect it with this positive. So you can use all these lines also as a positive. I'll change the color to a red color, and same way you can loop this negative with the top negative. So all these lines also can be used as a negative, right? And you know that it is horizontal. When I touch this, you see there's a green color line passing. That means that this entire line is connected. This is connected with the negative of your Arduino board, and this is connected with the positive of your Arduino board. Now when you see there is 3 pins in your servo motor, there is a ground pin, there is a power pin, and there is a signal pin. Ground, power, and signal. So ground can be connected with a negative. I'll make a connection to the negative. Ground, you can take it to the negative. And you take a power. So power will be connected to 5 volt. Just go here. So whenever if you click with the mouse, you can able to bend, and I need to go bend it down. So I will click again with the mouse. I will take it to the positive. So this is how we do the connection. So red for positive. There's like one more pin left. This pin is a signal pin. The signal pin can be connected with the pulse width modulation pins. All this 0 to 14, 0 to 13 is a digital pins. 0 to 13 is a digital pins. And you see there is a digital, and in parenthesis you see there is a PWM. PWM stands for pulse width modulation. So here some of the pins can able to perform pulse width modulation. It can able to like you can able to provide a pulse width modulation signal through this pins. Pin number 3, 5, 6, 9, 10, 11. You can see there's a sine waveform here. That means that in digital pin, the voltage will be either 0 volt or 5 volt. In digital pins, when you take digital pins, all these are digital pin. All PWM pin can be also used as a digital pin. In digital pin, when you give 0, like when you say low, it will be 0. When you say high, each pin will be having a 5 voltage. But this PWM pin, what you can able to do is you can able to control the voltage between 0 to 5. If you need to produce a 0 voltage, you can produce a 0 voltage. If you need to make 1 volt or 0.5 volt or 1.5 volt, any voltage you can create between 0 to 5. And in PWM, so you can able to generate 0 to 255 levels. 0 to 255 different variations you can create. 0 to 255 different variations you can create. So 0 will be like a 0 volt. When it is 255, it will be like a 5 volt. Between this you can vary the voltage in 256 levels, 0 to 255, it is total 256 levels. You can able to adjust, you can able to vary this. So that is an advantage when we use a PWM pin. This PWM pin will be used like a for our speed control. If you need to control a motor speed, you can use this PWM pin. Or if you need to vary the light intensity, we can use this PWM pin. And the servo motor also, you're going to control the angle, right? You're not going to just keep 0 and 180. You're going to have various angle between 0 to 180. So this should be connected with the pulse width modulation pins. You don't need to like get confused with this. You should know digital can produce 0 voltage, 5 voltage. If it is a PWM pin, it can produce 0 voltage, 5 voltage, and it can also be within this range. It can produce 256 different levels between 0 and 5. Now I'll just connect this. I'll just connect. We can connect with any PWM pin. Pin number 11 is a PWM pin. You can see there's a sine waveform. This indicates it is a pulse width modulation pin. Okay, we can have a different color for this. I'll take a green color. We have connected one servo motor. So first we can do the we can connect one more servo, then we can start the coding. I'll take another servo. You can keep this in a same like parallel with this. You can have this and you see there's a ground, power and signal. So ground, I'll take it, I'll connect it with the ground. When you do connection now, so if you do this connection 2-3 times, you will get familiar. When you start, you'll be having this connection will not be that much neat. When you keep doing, you can able to make a neat connections. And this is connected with negative. The power, you know that it will be connected with the positive. I'll take it to positive pin. It's not actually connecting here. I'll take a positive. I'll use this side, positive. For positive, I will choose a red color. Okay, then you can take another wire for the signal. You will take a signal, you will connect it to another PWM pin. Pin number 10, so 10 also will support pulse width modulation signal. So you can use PWM, and I'll change this color, okay, to a green color. So now we have like two servo motor connected. We can see how to program the servo motor. We have two servo motor connected. We can see how to program the servo motor. 1 second, I'll check. Okay, ma'am. So now we can do the okay. So we are going to do text based coding, C++ coding. I'll just choose text. You can do continue. And as we did in our previous sessions, I'll do remove whatever there inside a void setup and whatever inside a void loop. And we will be having like only one void loop and one void setup, right? Inside a void loop, if you need to create another loops, we can have a for loop or you can have a while loop. Okay, inside a void loop, if you need to create some loops, you can use either for loop or you can have a while loop. And I'll just remove these two command lines. And in the very beginning, first we are going to use a servo motor. So when we use a servo, I'll say servo 2. Servo 2 is connected with pin number 10. I'll do like pin number 11 and pin number 10. So this is what we should declare in a variable and inside a void setup. So in void setup, what you will do is your void setup, when you power up your Arduino board, your void setup code will run only once. What you put inside a void setup is you will mention like what is the input you have used, what are the pins you have used in your Arduino board should be mentioned here inside a void setup, right? And I will do like pin mode is a function. So here we no need to use pin mode when we use a servo. This servo library come with inbuilt function. Same like last class when we use Adafruit liquid crystal, we create an object. We created an object. Same way here also we should create an object. In C programming, if you need to create an C++, when you create an object, so first we should put the class name. This model name will be the class name. Last class also we did the same thing. We copied Adafruit liquid crystal. This will be the class name. The object name is your choice. It is like a variable name. You can give any name. I'll name it as uh, servo 1. I'll name this as a servo 1. Okay, not a servo. We can't able to name it as servo 1 because it is already connected. We have used a variable. I'll just say servo, I'll say like S1. As we have two servo motor, we can create two objects using this class. I'll take another servo. This servo is this class name, and I'll create another object name for the servo. I'll name it as S2. It is like a variable. You can have any name for a variable. Like I did S1, I did S2, right? And inside a void setup, what I should do is your object name. Like after in the last session, after creating a LCD object, we did like LCD dot begin, LCD dot set cursor, LCD dot print. Same way here we do servo. Your object name is S1, so I need to do S1 dot attach. Like a pin mode function, when we use servo motor, when we use the servo library, we should use this object name dot attach. It is attached with which pin number? It is attached with pin number 11. Either you can say 11 or you can put this variable name servo 1. You can put a variable name or you can put a pin number. So this is S1 dot attach. I'll do like S2 dot attach. S2 dot attach. This is connected with another servo motor. It is connected with pin number 10. You can put either pin number 10 or you can put this servo 2, which is assigned, pin number 10 is assigned with variable, so data 10. So servo 2, which is having the value 10, pin number 10. Now we did this void setup. Now we can go for a void loop. We can go for a void loop, and inside a void loop, first we can see how this is working. The angle currently the servo motor is, it is in 0. Okay, this side is 0, this side is 180. If you need to rotate this with any angle, like I will just try, I'll show you how to do this. So if you need to change the angle of the servo, if you need to rotate the servo motor, I'll change the first angle like servo dot right, like digital right. Here we should use servo dot right. I'll just change, I'll just give some random number and check. I'll do give us 40 here, and I'll do like S2 dot right. We can try to change this to 90 degrees, and you can check how it works. I'll do start simulation. When I do start simulation, your first servo will go to angle 40, another servo will go to angle 90. Start simulation. You see this is like moving to angle 40, move to angle 40, this is moved to angle 90, right? So this is the function we should use. You are actually, like you see, like if you know how to use this, you should include a module, and you should create an object. Once you create an object, we are going to use only two functions. One is s1 dot attach is a function, and s1 dot write, s2 dot attach, s2 dot write. Okay, if you know this, it is easy to program the servo motor. We did this. Now we can have like instead of putting this s1 dot write, s2 dot write, when you start this motor should be like in a closed, like I'll do like this both should be 90. I'll put this in a void setup, and I'll make it as 90, so it will look like it is closed, door closed. It will make look like a door get closed. I'll do start simulation. Okay, so now you see this can be considered in a simulation, like this just a prototype, right? You can consider this as a door closed, right? So normally the door is get closed. Now we need to connect a sensor which can able to sense a human, right? And so the sensor which we are going to use is a passive infrared sensor. We can call it as a passive infrared sensor or proximity infrared sensor, PIR. In short, we call it as a PIR sensor. This sensor is capable of sensing human or animal presence. So our human body will radiate infrared radiation. So with the infrared radiation, it can able to sense human or animal presence. So here you see. Okay, so if you need to read and understand more, you can see this here. I added a link, so you can go through this reading assignment later. And yes, so we have the sensor. I'll have the sensor in the bottom, so it should be like in front of a door. We are assuming this is a door, so I'll keep the sensor in front of a door. And if you need to rotate, okay, if you need to rotate any component, here you see there's a rotate option. So after you select this, you need to click rotate. So you can rotate like this. You can have over here. And yes, so same like other sensors, you see you'll be having a signal pin, you have a power pin, you have a ground pin. So ground will be connected with ground. I'll take this connection. There's a ground here. I'll just use this ground. And I'll take this power. I'll connect it with a breadboard. There's a 5 volt. I'll just connect over here. So I'll change this power to red and ground to black color. Okay, so we did this connection. Now we have another pin, which is a signal pin. You know that it is a digital sensor. This PIR sensor is a digital sensor. Okay, and so this will be connected with any digital pin. You can use any digital pin. I'll connect it with whichever pin is easy for me to connect. I'll just use that pin. So pin number 6 I have used. So PIR is connected with pin number 6. We can have a different color for the this signal pin. We can have a different color. You choose yellow color here. Okay, ma'am. So now we have connected this PIR. So we already program a digital switch. This is a digital sensor. So the program will be very similar. When you connect a digital sensor, the syntax will be the same. Now we can do the coding. This PIR sensor doesn't need any module, so we can straight away connect. I'll just do INT PIR, passive infrared sensor. I'll do like INT PIR equal to, and it is connected with which pin number? It is connected with pin number 6. It is connected with pin number 6. And what I should do inside a void setup, we can do use a pin mode function. Pin mode, you know that in mode M will be capital. Pin mode, in parenthesis I can say like pin mode, this variable name PIR. Pin number 6 we assigned a variable name PIR. So you know that all the sensor are input. It is going to take input. So I'll do like input. And last session, on the previous session also we did, like whenever if you have any sensor, either it is an analog sensor or it is a digital sensor, it is going to read a value. The sensor is going to capture some value. This value should be stored in a variable. So we need to create another variable. So I'll do like int. We can do PIR value. PIR value. To store the PIR value, I just created a variable. I initialized a variable PIR value. Okay, so now inside a void loop. So in void setup, you'll just mention what are the inputs you have used. You can also put like s1 dot write, digital write, all this, but what you put inside a void setup will execute only once, will run only once. What your main code should be inside a void loop. Now inside a void loop, okay, inside a void loop, and we are going to read some value from the sensor. We should see how the values are getting recorded inside this PIR value. So we can use the serial monitor. We are a developer, right? So for a developer, You can always use the serial monitor to see the value. But for end user, they need to have some display, right? They otherwise need to have like a mobile app or a website to see the values. Here, for as we are a developer, we can use the serial monitor. To use the serial monitor, we know that we should use a function serial. If you notice the serial, S is capital. So in the function, when the syntax also, we do serial dot, like lcd dot begin 16 comma 2. Here we need to do serial dot begin, and the speed of your Arduino board, it is 9600. It is called as a baud rate. We call this as a baud rate, 9600. And inside a void loop, am I going the correct speed? If I'm going like a little fast, you can ask me to wait. If you miss anything, okay, if you need any explanation, you can ask me. You can unmute your mic and you can ask. Okay, ma. So now S1, now we did like a void loop, same like your previous classes. When we have like we are going to read a value from the sensor. When you read a value, we are going to store that in a variable. We already declared a variable PIR value. So what I will do here, PIR value is the variable name, equal to, this is connected, this sensor is connected with a digital pin. It is a digital sensor. If you need to read a value from the sensor, we should use a function digital read. This is a digital sensor, so we use a function digital read. Okay, we do digital read, and we are going to read it from where we are going to read. We are going to read it from the PIR. The sensor is connected with the signal pin is connected with the pin number 6. We have a variable name for it, PIR. So you can put PIR for this. You did PIR. After this, you need to see how the value gets stored inside this PIR value. So for that, we can use serial. S will be capital, serial dot print. So when you do serial dot print, what you put in quotation, we can have a string, okay, printed. String is anything which you put in a quotation. I'll put a PIR value. It is a string. Even you can have like a space, anything. It is not a problem. I did like a PIR value. Let me keep same as a variable name. Even if you can have a different name, PIR value. So when I do start simulation, it will keep printing PIR value. So it should print, you should also display the actual value, like whether it is 1 or 0. It is a digital sensor. It is going to have only two possible values. It can be 0 or it can be 1, right? So I'll do, to print that, I'll do serial. I'll use another serial dot print. If I do use serial dot print again, this will be like horizontally keep printing in the same line. It won't be like easy for us to read. To after this print a value, when you do ln, after printing a value, like if the value is 1, after printing 1, ln will create a next line, so it will go to the next line. So when another value comes, it will get printed in another line, not in the same line. So now we need to print the value. The value will be available in a PIR value. So I'll do like PIR value. Okay, ma. So serial dot println PIR value, semicolon. Now we can also add a delay. Otherwise, it will be running very fast. I'll add a delay. Usually you use any value like less than 1 second or 1 second, whatever delay you need, you will use that. Okay, so delay I'll do like 1 second. 1000 millisecond will be, millisecond is 1 second. Here we should provide in a milliseconds. Okay, ma. So delay 1000. Now you do start simulation. So serial monitor, when you open a serial monitor, PIR value is 0. So if you need to simulate a motion, just touch the sensor. When you touch the sensor, this can be considered as a someone in front of a door. We can just make a movement. When it moves, you can see the value, PIR value changes to 1. Then it goes back to 0. So at the moment when it sends, like value will be changing from 0 to 1. After 1 second, then it go back to 0. So you see, this is like a region of interest for you can see like it shows this, right? This is a region of interest of this PIR sensor. If there is any object within this range, it can able to detect. I'll do stop simulation. Now based on this, we should open this servo. The servo is like in 90 degrees. If you take it back to, if you need to, if you do 0, if you need to, if you change it back to, if you need to take the servo back to this angle, we need to do servo dot right 0. So when we should do it? If there is motion detected. Okay, if there is a motion detected, if there is a motion detected, PIR value will be 1. In that condition, so you should open the servo motor. So I'll do like if. In C programming, when you give a condition, it should be given inside a parenthesis. In Python, this is optional. Even you can do without this parenthesis, you can give a condition. And based on the value PIR value PIR value equal to. So to check equal, okay, this is the common mistake we'll be doing. So you'll be using single equal to. We should not use single equal to. Single equal to is used to store a data in a variable. But to check equal, we should use equal to symbol 2 times. And if the PIR value, if it is equals to 1, if the PIR equal to 1, so what should be done should be given inside a opening and closing curly bracket. If the value is 1, what you should do should be given inside this curly bracket. What you should do, we should open this, like the closed door should be opened. This can be done using s1 dot write. I'll just copy this s1 dot write. I'll put over here. And what should be the angle I should use to take it back to this 0? It should be 0 0 0. Okay. And like when we use if statement, we should also have else statement. If it is 1, when it is 1, it should like it will be like, I'll show you without putting else statement. I will show you the output when I do start simulation. When I do start simulation, you see the door is actually closed. When I simulate a motion, the door is opened, right? And it remains open. Why it keeps remains open? Because there is no else statement. So if there is, when it goes to 0, it should close again. So what I should do is, I should have a else statement here. If you are not using else statement, whatever inside this will be like, it will be always in this state. It won't change to closed state. So what I should do, I should have a else. And another common mistake we will be doing is, like the beginner will do is, like they will be putting a condition for else. Okay, in any language, only if else if will have a condition. For else, we should not put a condition. This is a common mistake like a beginner will be doing. So once you get familiar, then you will be clear with this. Else should not have a condition. So else, I'll just copy this s1 dot write and s2 dot write. I'll put this inside, and you can change, you need to close it back. So I'll do 90 and 90. Now you do start simulation. You should check stage by stage. After connecting a servo, you check the servo. Then you connected a PIR. We tested this PIR, right? So stage by stage, if you are checking, it will be easy. Start simulation. It is closed. When I simulate a motion, it will open, and it is getting closed. If you need to remain this open for 4 seconds or 3 seconds, or you can have a delay here inside the if statement. You can have a delay of 4 seconds or 3 seconds. If you need to add 3 seconds, you'll do 3000. If you need to add 4 seconds, you do 4000 milliseconds, right? If you have any doubt till this part, you can ask me. So we did. Now we need to connect one more thing. We need to connect a LCD. We need to also include a LCD. Okay, ma'am. So if you have any doubt till this, you can ask me. Okay. So hope everyone have understand this. Even if you miss anything, you just you have this recorded session link. You can go through that back, and you can. It will be easy for you to like recap. Okay, ma'am. So now we done this. Now we need to do the LCD. We can also add a LCD for this. LCD. You see there's a 16 cross to I2C LCD. We can take an I2C LCD, search for LCD. This is an I2C LCD which have like only 4 pins. So I'll just place over here. And you have a ground pin, you have a VCC pin, so same, like you know the connections. Now you know the connections. When you do a real hardware also the same, everything is same when you do this. So you also later, you when you get an opportunity, you try with the real hardware. In VCC I'll make it ground, sorry, ground I connected with negative, VCC I'll connect it with the positive. I'll make it a red color. And we have STA pin and SCL pin. I'll take a STA. Wherever if you need to bend, just click with your mouse, you can able to bend it. And it should be STA should be connected with the STA. So you see there will be a STA here. This is SCL and this is STA. And the color, you can have a different color. I'll take it to yellow. So I'll take SCL. Instead of just passing like this, just bend over here. This is connected with SCL. So STA and SCL connections done. Now we can do, like we completed a LCD connection. Now we can do the coding for this. Code. Now what you should do, last session what we did, when you connect a LCD, we need a library for the LCD. To include a library, you just click on this libraries. You see there's a Adafruit liquid crystal library available. Just click include. So you included Adafruit liquid crystal. So once you like import servo.h, you created an object ES1 using this class name servo. Same way, when you take any module, any library, we should create an object. So this Adafruit liquid crystal, what comes before this .h is the class name. We call it as a class name. You just copy this, you can paste over here, and we should give like S1, you should give some object name. It can be any name. I'll name it as LCD as a object name, liquid crystal display, in short LCD. You can have any name, okay, like S1, S2. You can also give S3. And here we should give the address of your I2C LCD. In a simulation we can just give 0, okay, but in when you get a hardware, they will provide a like a hexadecimal code, okay. It will be like you have two possible hexadecimal code, as I mentioned last time. You can, okay, it will be 0x27 or it will be 0x3f. So that should be given when you connect a real hardware. Otherwise the remaining code, everything will be same. Now how do you start, how do you mention that in a void setup? What you should do inside a void setup, like serial.begin, we need to do LCD is the object name. Like you did s1.write to use a function write, we did object name dot write. So here object name is LCD, we need to do LCD. Like serial.begin, we need to do LCD.begin. Serial monitor is available only for the developer. End user will not be using the simulation software, or they will not be using any Arduino IDE. They need to see the value from a liquid crystal. So LCD liquid crystal display or any other display. LCD.begin, we are using a 16 cross 2 LCD. That should be given here as 16 comma 2. 16 comma 2, it is a 16 cross 2 LCD. If you are going to use a 20 cross 4 LCD or a bigger size LCD, you should put that number of columns. 16 means there are 16 columns and there are 2 rows. 16 columns can display 16 characters. 2 row, when you do display in first row, if you're going to, you can display 16 character. In the second row you can display a 16 character. Total 32 character you can display here. And yes, now we did this. Now inside this we can also have a message. I'll do like LCD dot, I will select a cursor. I'll do like set cursor. In set cursor, C should be capital. So like a digital, right? W is capital. In pin mode, M is capital. Same way, in cursor, C will be capital. Set cursor. If you need to display in the first row, in the first column, this is first row and first column. First row, first column will not have numbers 1. It will have 0, 0. If you remember in Python also, when we do indexing from a list or indexing from a string, the first character will be having index number 0. Same way. So 0, 0. Now you can have a semicolon. And after this you need to print. So if you need to print, we can do lcd dot print. lcd dot print semicolon lcd dot print, and we are going to do print as automatic door. Automatic door. You can have print anything like automatic door. I just printing here as automatic door. And so in if condition, so inside this if statement, I'll do like before a delay we can print, or in the very beginning we can print. You don't need to print after delay. I'll do like lcd dot set cursor. Set cursor. I need to select a second row and first column. So second row, first column. First number what you put is for column. So it is first column will be 0. And I need to select a second row. Second row number will be 1. So I do set cursor 1. So I'll do like lcd dot print. I'll say like door opening. Door opening. Okay. And so this is, in this case we are going to show like, we are going to print and show like door opening. So I'll just copy this again. Here in else statement, when it get closed, we should show like door closed. Door closed. Okay, ma. So we can test this. We have completed. We can just test how it is working. We can do start simulation. Door was not declared in the scope. Okay, we missed a quotation for this. Like it is a string, it should be inside a quotation. We should have a quotation. So now when you do start simulation, it will be working. Start simulation. Here also we missed a quotation. Okay. Yes. Now we do start simulation. So we can see how it works. When I do start simulation, code, you can go, just click a code to hide this. Automatic door. Door is actually closed here. Okay, so we can simulate a motion and we can see, you can observe this LCD and this knobs of the servo motor, shaft of the servo motor. Just click this. So when I simulate a motion, you see like what happens. I'll just simulate again. Door opening, it shows like a door opening, and door will get opened. It will be door will open for 4 seconds. We added a delay of 4000, so it will be waiting for 4 seconds. Okay, after 4 seconds it will automatically close. Simulation is running little late, otherwise like it won't take this much time. So you see door closed, you get a message door closed and door gets closed. Okay ma. So we have completed for today's session. If you have any doubt you can ask me. Okay, so right, I hope everyone understand. If you missed anything, you just go through the recording. The link will be available. I will share you the link in a group also. Okay ma'am. And for today's session attendance, I will share you the attendance link. The attendance link will be available here. Smart systems with Arduino, like this link is already available in your WhatsApp group, right? In our WhatsApp group you have this. You can submit your attendance by just clicking this link. For today's session, you can use this link. This link is available in our WhatsApp group also. I'll share you in group now. So this link I will share you. Okay, if you open this link, you will have if you scroll down, you will be having your attendance link. This is your student diary, that's why I'm putting here. Wait, I will share you the link in a group. You can go through you can submit attendance by clicking a link in a group. Okay, ma. So the link is shared in our WhatsApp group. Just click this. Once you click this link, it will take you to the student diary. If you scroll down, you see your attendance link here. Just click on this attendance link and you can post. The student diary link is available in your WhatsApp group. You just click the link. I can see like, okay, students are joining here. Once you join, you scroll down, you click this attendance form and you can submit your attendance. So thank you everyone. We have completed for today's session. See you all. If you have any doubts, you can ask me. Thank you, ma.
Thank you, sir.
Thank you, ma. Thank you.
Sir, attendance.
Attendance link, it's there in a WhatsApp group. Okay. So in WhatsApp group, I shared you this link.
Okay, sir.
So once you open, you scroll down to this attendance form.
Okay, sir. Okay, I got it, sir.
Okay, ma. Okay.
Okay.
Okay, ma. Okay.
Sir, I have one doubt, sir.
Yes, ma.
Sir, I have not joined in the Tinkercad classes, sir. How do I join?
Tinkercad classroom, right? I'll give my WhatsApp number. Can you put a message here to this number? I'll share you a link. You can join through the. So I'm sharing you the WhatsApp number. You just message me. You can direct message me. I'll send you a link.
Okay, sir. Thank you.
Mm-hmm. Okay, ma. Okay, okay. Yeah, I will share you in group itself. I will share you. You can just take the link from a WhatsApp group. Otherwise, you can direct message me. I can send you in a message also.
Thank you.
Thank you, ma'am.